It's time to consider some scenarios for the future now that we should be planning for. If we're really serious about meeting zero emission targets by 2030-35, and it's obvious that we're not going to be doing that in a hurry, the way we're going, it'll be a very different world to the one we live in today. And we need to understand what kind of world that looks like and its impact on the way we live and ultimately the transport task. One might call this the ideal scenario which we may hope to survive as a species. Others might call this mission impossible. A more pragmatic scenario is we may fail to meet the targets, continue to muddle along in a world that becomes increasingly hostile place to live, supports fewer and fewer and ultimately no people at all. That's a pretty grim scenario, isn't it? I don't think that's where we need to go. I'm going to ask Peter to look briefly at a scenario for the future, for the medium term, in which I think we do the best we can. Is that right, Peter? Before I do, I better introduce Peter. Peter is one of our best-known economists in the development and application of macroeconomic models. Since co-founding NIRA in 1984, Dr. Brain has participated in over 200 economic consulting projects, most of which he has directed or co-directed, and this includes past and ongoing projects in South Africa, Australia, New Zealand and plenty more, I suspect. He was one of the few economists to forecast the economic crisis throughout the Asian region and participates widely in debate on issues of general economic interest. Peter has co-authored or authored 4 books, including Beyond Meltdown, The Global Battle for Sustained Growth. So please welcome Peter.
Thank you very much, Roger. Well, I'm going to complement what we'll try and achieve here is a multifaceted. First of all, why are we bothering about all what we've been talking about today? Because we think that the damage costs of climate change are worth the effort. And so the primary strand will be to look at the damage costs on the economy going through to 2100 from the various scenarios. Now, the second strand will, of course, to make sure we don't meet the full damage cost, is undertake mitigation costs. All the things that's been talked about previously today. So we'll look at the costs of doing that. But the third cost is also one that's often not thought about too much, is because if the world is to achieve net zero, a lot of our exports, fossil fuel exports, will no longer be required. So in addition to the mitigation costs, we have the costs we've got to replace a lot of our export-oriented industries if we are to enjoy the same standard of living as we enjoy today. Now, this is a tall ask, and I've been doing this for years, but I get very confused with forecasting and baselines and everything like that going out to 2100. It's not very transparent. So today I'll look at it very simply. We simply take do it all from the perspective of an average Victorian household circa 2019-20. That is, for an economy frozen in 2019-20. It's much easier and you avoid a lot of issues which complicate the analysis. And what we're going to try and get to, is it all worth it? Is the costs of electrifying the economy, building up our export replacement industries, worth the offset? Is that going to give us a net gain compared to the damage costs? And then we've got an emerging additional crisis, and that is the security crisis with the arms race that's going to develop in this part of the world, is developing this part of the world. You could argue it's linked, especially in high damage scenarios, but this one doesn't. It's got an independence to it. The other reason I like what we're going to deal with is a fixed economy as at 2020, where it's resource constrained. So in 2020, households consuming, buying motor vehicles, going out before COVID, entertainment, going on trips and all that sort of thing. And a lot of the analysis is done in terms of the impact on GDP. It's irrelevant. As a welfare measure, because if you think about it, one of the best ways to stimulate GDP, at least in the short term, is to go out and blow up things or burn them down and replace them. What's important is not that economic activity, but it's the cost to your living standards as you define it to pay for this. So that's not GDP. It's what I call household discretionary expenditure, or that part of household expenditure which gives you real welfare. And of course, paying for it is not only just through on the household budgets directly, but a lot of the costs are indirect. Well, household budget in terms of increased insurance costs, but indirect through the fact that governments have got to spend more on investment and current expenditure to offset these damages, which in a constrained economy has to be paid for through higher taxes or higher inflation. So a very simple, very, very simple model. So we're looking at three scenarios: business as usual, a pre-COP26, which is the current policies now, and ZNet 2050. But the only two ones we're really interested in is 1 and 3, because that gives us our benchmark to compare the other costs we've got to incur to ensure we go from 1 or 2 to 3. Now, where we're at, this is a nice little graph that Martin Wolf put in the Financial Times a couple of weeks ago. It basically just says we're after COP26. It just basically says with current policies, it's 2.7, and then he goes through the current commitments, whether to 2030, what that'll take it down to, the current binding commitments, and the intentions. So if all goes well, then we're not too far off the 1.5 that ZNet 2050 is supposed to deliver. So that's a little bit of hope, but of course we've got to go from current policies there to here, and that's a big step. And if most government policies are like the current federal government one, you'd just keep us at current policies. So, okay, these are the emission scenarios. Don't take any notice of them, just the emissions it's the temperatures that are important. So what we're trying to do is build up the damages that it's going to happen, if you like, in reverse from 1.2 to 4 degrees to work out the damage on the economy. Well, the seminal work is the IPCC report of 2018. This is the basic source of the estimates that's gone into this. It just looks at, by category of damage, what is the cost that's going to occur between now and 2100 in terms of the difference between 1 and 4 degree outcomes, centigrade outcomes. So you take that report. There's been a lot of other studies that have been published since that haven't been incorporated in the 2018 report. They rule off a year earlier. I've looked at if there's been studies that have updated those damage costs. I've used them, not just simply the IPCC report, to try and calculate everything. This is the how in 2100 in relation to the 4 degree scenario, or business as usual. Well, business as usual compared to 1980, I guess. The composition of the damages, natural disasters, fire and floods and so on, is 49% of the damages from the perspective of 2100 at the 4 degree mark. Productivity loss and GDP loss, labour productivity loss, and GDP loss through agriculture, damage through the environment is 36% of the damages. Sea level rise is 3.5% rise. In early analysis of this, I put in defence, but I've taken defence out because, you know, at 4 degrees with 400 or 500 million people on the move, well, we wouldn't exist anyway. No amount of defence spending is going to help. But anyway, an agricultural price rise, which is different from the productivity impact on GDP, 11.7% of the total. So that gives you the distribution of damages we're trying to avoid. It's a very simple model, and this is it. Tony doesn't like modelers. He would have no problem here because it's as simple as 1 + 1 = 3, no 2. We start with the GDP identity, what it is. Now, and that's the components of GDP, well, I left it that one, government current expenditure, GC. Consumption, investment, exports minus imports. Now, we are starting from the proposition that GDP is constrained by your population and capital stock installed as at 2020. And you're imposing all these additional resource costs on the economy because you want to offset, you've got to pay for the damages, but you want to offset those damages. You want to build up the renewable energy stock that at a greater rate than you're otherwise doing them, or accelerate the motor vehicle take-up for electric cars, so more, you know, expenditure there than you otherwise would have done in the absence of all these pressures. So GDP is constrained, but you've got to make a choice. What do you want to do with what are you going to make? How are you going to make it? Of course, GDP is constrained. What do you want to forego to pay for all this? And the other thing that's constrained is the net trade balance. All my life, Australia has been balance of payments constrained, except now. In the first time in my working life, Australia is not balance of payments constrained, but the bad news is that once world interest rates start to rise again, and the Chinese get through us in terms of our iron ore and other things, we'll be back to a balance of payments constrained situation. A lot of it at the moment, the strength, of course, is the iron ore price and the very low interest rates we're paying on our net debt. But that'll evaporate over the next 2 or 3 years. So with those two things constrained, we've got to live with our balance of payments constraint and our GDP constraint. Then consumption expenditure, or welfare if you like, is simply, if you're going to increase your investment costs to electrify the economy or motor vehicles or build freeways or whatever you want to do, not freeways, build things that, public transport systems, you've got to take it off consumption. And the same with government expenditure. If that's paying out a lot more for costs of natural disaster costs, it's got to come out of private household consumption expenditure. Very simple model. So it's just forcing people to face up that all this has got to be paid for by hook or by crook. The question is, well, yeah, okay, so okay, but what we could cut government expenditure, couldn't we? You could, but that takes you straight back into the welfare, the income distribution argument. You know, most people are dependent on government expenditure for health and education. It has very strong redistributional consequences. So what we're saying here, by that little simple identity, we're making that those who can pay the most. So to minimise the impact on the income distribution. And when you look at all the resource constraints on the economy in the years ahead, where we've got to make these decisions at a much greater scale than we have been making up to now, the tax cuts project, you know, in law for 2023, 24 are an abomination. Well, I've gone through the damage costs. I explained all that. So we get the damage functions, we look at the different scenarios between 1 and 4, interpolate between the benchmarks, benchmark everything back to 2020 in terms of the value of our fixed capital stock that can be damaged, and then we apply the ratios out of the IPCC report or subsequent modelling that's been done. And this is the result in terms of an average Victorian household. You can see there the first 4 blocks goes through 20, 40, 50, 75. It's just the average expenditure for the average household reduction to create the resources. This is just damage only. And the next 4 columns are the percent. It's very similar because the average household, when you take a Victorian household, when you take into account imputed rent, it's over $100,000. So that's why the percentage and the dollar thousands look the same. So you can see there, I suppose the bottom line is for 2050, in terms of the third last column, for ZNet 2050, we're paying a damage cost of 1.5% of average household expenditure in Victoria, based on 2020 benchmarks, and or if you like $1,900, and that's in terms of total expenditure. But if you take out those things that add nothing to welfare, or are in part a tax, like health and part of consumption or energy costs, nobody gets any value at all out consuming 10 petajoules of energy. What they get out of it is, of course, the ability to do things, but if they could get that at no cost, they'd be infinitely more happy than paying for it. So we take those out to get at that true welfare measure, if you like, to make discretionary income, and you can see there the percentages are greater, but of course the absolute amounts won't be. So under the 4 degree scenario, the damages being inflicted on the economy is 31% reduction in total expenditures for an average Victorian household to pay for the insurance, extra insurance, government posing taxes to pay for rebuilding or repairing or protecting infrastructure and so on. That by 2100, that comes to 31%, or a cost impost of $40,800 in total. Okay, you want a sniff test. There's your sniff test. That previous table, when I write out all the year-by-year costs on the Victorian household, I get the total cost, add up to 1%, total cost, and then compare that to the estimate in the IPC report, which was $551 trillion US dollars. I get the Australian share of that at 1%, was what you'd expect. Because we're about at PPP exchange rates, we're about 1% of the world economy. A bit more in terms of probably assets. All right, so we've got our damage costs up 31% of total household income by 2100 for our average household benchmark back to 2020. Now we want to get into all the resources we've got to mobilise to offset that cost. This is a very basic CO2 reduction strategy. It's called electrification of the economy. What's the simplest thing, of course, without the... I'm not going to say, I'll come back to that. Step 1 is simply obtain a 100% renewable source eventually, which is electricity. Convert everything you can to electricity using, and then you do what you can, such as soil carbon or carbon capture or whatever, for the balance. That's the simple strategy. But in terms of the electrification strategy, it's nowhere near simple. Yes, we can convert the remaining, whatever it is, percentage of our existing fossil fuel capacity to renewables. That's a straightforward step, but it's much more complicated than that, because you've got to do all the things listed there to add on to those costs, which are, first of all, you've got to, you've got to upgrade the grid, you've got to put in batteries, you've got to put extra capacity in, even at 2020 levels, for electric cars you want running around. I haven't taken into account trucks, but cars I have, 100% electrification of cars. And also what you've got to do, you've got to put extra capacity in to put electrification of industry, getting rid of all, as much as you can, getting rid of all those processes that use gas and petroleum that can be electrified. And also on top of that, the people who have those non-ZNet ready equipment, they've got to also pay out to convert that. Now, we've got to be very careful here. It's very easy to get up very huge numbers, but what you're trying to say is, what are the net additional costs? Now, a lot of these. What is the cost of, somebody who's got a gas heating process? They've eventually got to replace that. Now, it is true that heat pumps come out at a higher capital cost, but a lower net overall life costs in general. There is some net additional capital costs, but in terms of looking at an economy at 2020, you've got to be careful not to, overgill the lily, because a lot of those costs would have had to be made anyway, admittedly on alternative technologies, but now can be devoted to what you want. So I've tried to be very careful here, is not to blow the whole thing up to become, just ridiculous, but I've taken that into account. And I've done that sort of best here. These are just percentages of the cost components for electrification of the economy that I've outlined previously. Just put the dollar billions or millions into percentages. Now you can see the total expenditure to do that gross comes to $1.2 trillion. There's $1 trillion everywhere in this thing. Just think of everything's got to cost $1 trillion. You'll be very happy. But of course, because of the fact that we are already, of course, building renewables, so we don't double count that. But the building of rate of renewables now is only about a third of what we need to do to reach ZNet 2050. And the depreciation allowances. Well, there's not much depreciation allowances in the fossil fuel, because the buggers are simply just running down their short-run marginal cost. They're not going to be in existence. Who cares about depreciation? They're just running down their plants and running down their short-run marginal cost. But there is obviously, we've got to take into account by the fact that we are building some renewables, but only about a third of the capacity we need to do going ahead in the next 20 years. So that gross figure of 1.2 trillion, once you take into account of what's already been done, comes down to about $856 billion to electrify the economy, excluding trunks. The next graph just shows how the net figures now, how we have to build up our rate of expenditure to get to ZNet 2050 compared to what we're doing in terms of the electrification effort. All right, industry restructure. You'll be very glad there's only one slide on this. So this is just a thought experiment. We've got to replace about $150 billion of exports. I've put in about 25 billion of iron ore exports, because I think that'll be taken out of the equation, as standardising the economy at around about now. We have a capital investment in the oil and gas sector now of $600 billion. That would largely, under a ZNet, a hard ZNet 2050, a lot of that would become sunk capital, but it's capital we would have to replace in other things. And there's good prospects for that. There's great prospects in just the standard things like copper and zinc. That's going to be in great demand as we move through towards ZNet. rare earths, lithium. So we can do that transformation given our resource base. The big thing that sticks out is what we're going to do with the oil and gas, especially, of course, the gas. And what I've done here is, okay, let's assume we can replace the natural gas with hydrogen. If we can work out the way how to transship it reasonably. Now, the big cost of hydrogen, of course, is the renewable investment you've got to put in to produce it. You've got to get your renewable costs down to about between $10 and $20 a megawatt hour, which requires will require massive scale plants, not close to home. So that would come out at about just for that alone, would come out something like nearly $800 billion of investment in renewable capacity for the hydrogen. Just to make sure that I'm not off in cockatoo land, I've off at the ferries, I've just benchmarked it against the so-called energy hubs that's been proposed for Western Australia in particular, and it seems to come out roughly in the same area, the same value. But these are all very preliminary figures. But anyway, it's all we've got to work with now. So if you put all that together, replacing the non-LNG investment in oil and gas, cuts coal mainly, then yes, that's quite doable. On the preliminary estimates for the hydrogen economy, we need to spend about $1 trillion. Again, but taking out the fact that we've got in the economy now, as at 2020, plenty of depreciation and indeed some net growth from the oil and gas industry. It's not as bad as that. It comes back to about $761 billion when you net off the replacement and net growth expenditures you're now getting now. Therefore, you're keeping your constrained economy balance going. The complementary security crisis, I think it's reasonable to assume that we'll have to match America to reach 4% defence cost of GDP in the coming years, and the submarines by themselves seem to absorb about 25% of that. But if you look at AUKUS, or whatever they call it, it's not just submarines, it's a lot of other stuff there. So that would certainly be the sorts of levels that people are talking about looking ahead. Now this is the bottom line, and the second last slide, you'll be glad to know. And so what we're trying to do now is add all that up, the climate change. Now you can see there that electrification costs, just all that, whatever it is, $800 billion of expenditure imposed on an economy over the next 29 years to get ZNet. That's going to cost the average Victorian household, in terms of releasing resources as of 2020 to do that. It's going to require a cost of $3,400 by 2040 and $5,800 by 2050 and by 2100 $4,600. And you're saying, but we've reached ZNet 2050 by 2050. So why do we still have the echo costs? Because we've had to put so much more capital investment in the economy. The 2100 figure is the replaced depreciation rate. You've got to replace the capital stock you installed 25 years earlier or 30 years earlier. Because we're to get these solutions, we're massively increasing the capital base of the economy, and therefore you have long echo effects in terms of impact on living standards down the track. ZNet export replacements is about the same in terms of percentages, and yes, it reaches a peak at $4,500. That's to release the resources to build the capital investment in the hydrogen and the lithium and all that by 2050. But then you have pretty strong echo effects going through to 2100. Security, it's about 3.5% of living standards to build the submarines and all the other stuff goes with it. And then you get your total, if you add all those up, total, you get in 2050 a total cost on average Victorian households of $14,300 or 12.6% of total average expenditure. Now, is it all worth it? The second last line in the table is I've included the damage costs for the ZNet, but excluded the security, which hangs off to the somewhere out there. It's sort of just an indication of the demands that will be competing for climate change type expenditures, damage mitigation expenditures. So is it all worth it? That's the last column, excluding the security issue, which is not really relevant directly. And so when you put it all together, by 2050, in terms of the total average Victorian expenditure, you have 4,500 net loss in household expenditure, and in percentage terms 4.7%. But by 2100, that's the peak, because we're really spending at high levels in 2050 to hit our targets. But by the time we get out to 2100, compared to the 4-degree scenario, we're $28,400 better off, or 21% in terms of average expenditure. And the discretionary percentages are a lot higher, though the absolute amounts are less, higher, but the absolute amounts are less. They're discretionary now. So in terms of real welfare, if you like, you know, doing the things people like to do, like spending on restaurants and quality food and everything like that, they're 26% better off. What does it all mean? Well, it also shows in terms of the current generations, current older generations, and wishing to protect their tax cuts, it's going to be a hell of a problem to reach ZNet 2050 and apply all the capital expenditure we've got to do to mitigate our damage costs. In terms of the younger generation, not so much, but in a growth context, of course, the solution would be to try and accelerate productivity growth, which takes you to all the thorny issues of population growth, migration, and those sorts of things. But the issue there is, of course, you want to accelerate productivity growth, especially in terms of an idealised economy at 2020, you'll have to increase capital investment considerably. In terms of the previous speakers, those electrification costs, of course, can be reduced by the sorts of things that they're talking about, like John's, behavioural change. If you can get more people to ride share, you'll save some of those cost estimates I've got for electrification of the motor car industry, of the motor vehicle fleet. Same with Tony. So that's where all that comes in. It reduces these costs or the hit on living standards. The more you can get efficient responses that are low resource intensive, that do not directly impact on living standards or resources that have to be reallocated, the better off you are. However, as the last point makes, you don't want to go troppo on this, because you want to pick those things where the cross-price elasticity is high and where the responses for the cross-price elasticity effect gives you a level of real incomes which is not too different from what you had before. So that means, in terms of private public transport substitution, you make sure before you put in pricing charges, you've got a good public transport system that's there to take up the opportunity created by that, and we all might survive. Otherwise, we're dead.
Thank you, Peter. Well, 4 degrees, I don't think anyone will be here. Before we move on to our Q&A session, it's worth pausing to reflect more deeply on all of this. Firstly, getting back to the environmental imperative to transition to a new world, a zero-emission world, and do so very quickly. We don't know what the world really looks like, but it must be one that places less demand on the planet with a much lighter footprint than exists today. Limits to growth are going to hit us really big time. Not just a little bit, but by orders of magnitude. This will be a world that pollutes less, must restore the damage done to the biosphere, and consumes less of everything, including transport. And the question is, can we make this transition within the limited time we have left? By 2035 at the latest, but ideally 2030. Talk about zero emissions for transport is meaningless on its own. As John explained, the future of transport depends on the future of the city and the ability to make this transition to a world that no one really is talking about, let alone have a plan to get there. The city model we have developed is based on fossil fuels. The early transition is one that continues to use them, but more efficiently. But what would the model look like if they were removed completely? We can see what cities looked like before the fossil fuel age. They were tiny. The food required to support them was grown in and around them, and people did not travel far to work. In fact, most people lived on the land or adjacent to waterways that produced food. And food's going to be quite important in the end. People may argue that technology will solve this problem, but some of the technological solutions politicians and others are counting are unproven. And Peter and Tony referred to that. And they may never be feasible and may arrive too late or to be of value. As the UN stated recently, to rely on unproven technology in this situation is both reckless and irresponsible. This means we must use and refine existing technology as best we can to start with, but even then there are no magic bullets, and a technology-driven strategy will not be enough. It will have to be accompanied and driven by behavioural change. It's important to apply lessons from the history of past collapses of societies and civilisations that have occurred over thousands of years, and there have been plenty of them, and that is a very common recourse to using technology rather than changing behaviour. Nations and politicians continue to be mesmerised by technology and the belief that it will solve our problems, but it has often been the abuse and overuse of technology that has got us into this mess in the first place. We're repeating the follies of the past, and it'll end in tears. And we should know what failed cities and civilisations look like. Archaeologists certainly know what they look like. They've been digging through the remains that have often been covered by centuries of sand, dust and vegetation, abandoned because they could no longer support the population that lived in them. If we want to avoid a similar fate, we better start thinking about the kind of model that can survive the environmental challenges we are facing and develop a plan to manage the transition. John and Tony have provided plenty of actions that can be used to rapidly reduce transport emissions now, and it is imperative governments respond accordingly. But this only buys time, a little bit more time, to address the most fundamental question and ultimate challenge of achieving zero, and there is increasing pressure to do so. This pressure is becoming increasingly broad-based. It's coming from industry itself that wants government leadership and intervention to put us on this path, the community, and it'll vote accordingly, international pressure from other governments and countries who see us as a laggard and will seek to impose penalties of all kinds to encourage us to lift our game, an increasing body of environmental case law which will impose penalties on recalcitrant governments and corporations, and two cases in The Hague are really relevant in this situation, one against the Dutch government itself, a sovereign state, and one against Royal Dutch Shell, and it's likely more will follow. It'll come from our scientists who will continue to present evidence that demands action and positive responses to our environmental challenge, and from changes in the natural environment itself and the capacity of the planet to support life, which will put increasing pressure on communities to adapt. One thing we can be certain of, we will not get there based on business as usual and the thinking that underpins it. This means, amongst other things, abandoning the current dogma of continuing population and economic growth to improve living standards. There are limits to growth. We can't keep on doing this. And because we have so little time, we need to look at ways in which we can turbocharge the process of change. I talked about lessons from history of past failures, but there are also positive lessons that can be learned from earlier crises that did not end in collapse or failure. These were situations in which governments recognised the threat and declared a state of emergency and used it to create an environment in which rapid change and adaptation was possible. Examples include World War II, the OPEC oil crisis, the ozone crisis, and even our latest pandemic, which enabled vaccines to be developed within a year instead of the norm of 15 years. But we need to look at where pressure for change is coming from, to reinforce the positive directions and use it to our advantage. Use it as a pathway to adaptation, instead of fighting it in an effort to maintain business as usual. This is a huge challenge, and Professor Rockström from the Potsdam Institute for Climate Impact Research based in Germany has argued the scale and complexity of the task is huge, and he compares it to an Apollo project. We argue that a government response to zero emissions must be pursued on the same basis. It needs a plan, of course, but this must be supported by the organisation and political structures required to make it happen, and it must be given top priority. The question now is how to start this process and what are the most powerful levers for change. Now, this is the subject of a short paper by Donella Meadows, which I often refer to, called Places to Intervene in the System in Increasing Order of Effectiveness. Now, anyone who has read Donella Meadows' papers on systems thinking and ways to change a system will know that the place to start is the mindset. That is, the accepted assumptions about what the problem is and what are the solutions. If you want someone to do something for you, it's fairly easy if they want to do it. But if they don't, you have a challenge, and that challenge is to change the mindset that determines what they do. The starting point must be to change the political mindset that is driving our system in a way that generates the kinds of outcomes we don't want. If we cannot change this, we will change very little. So how do we change the collective mindset? The answer is very clear. Declare a state of emergency, in the same way it was declared at the start of World War II or the OPEC oil crisis in the 1970s, or even in the same way as pharmaceutical companies responded to the COVID crisis with a total reorientation of priorities supported by new rules and government legislation. But this will also require a change in the mindset about community, society values, aspirations and sacrifices required to adapt and survive, and the value placed on the future of our children and future generations. It's a mindset that must be driven by the broader community that forces our political leaders to respond. It's a mindset that must understand the environmental imperative and accepts the fundamental need to stop poisoning our planet with greenhouse gases and reduce the demands made on it by not polluting and consuming less of everything, including transport, by travelling less often and more efficiently. Every trip made by a fossil fuel-powered vehicle is poisoning our planet, and the sooner these are removed, the better. Once the message is clear, use all the other levers outlined in Meadows' paper, alone or in combination, to do whatever is necessary to force system change, starting with the most powerful. So I'd like to summarise as follows. Firstly, it's critical we change the current mindset. Business as usual must be abandoned, and the thinking that underpins it. We need to change the social and political culture that promotes business as usual and create a new culture, values and expectations driven by a mindset that supports the need for change and the outcomes required. And more specifically, we need to find a new model for our city that will survive in a zero-emission world. Now, this is a huge challenge, but success will ultimately depend on the extent to which this is accepted. In fact, without it, the prospects for achieving our environmental goals and achieving emission reduction and zero-emission deadlines are zero. Secondly, transport solutions must be based on an understanding of the transport system itself, how it works, to identify levers for change that can be used to meet our environmental goals and targets. We know what a lot of these are. John has gone through them. There's certainly some of them, but there are a lot more, and we need to know how to implement them. And we need to do it now. Thirdly, vehicles are only part of the solution, and reliance on technology alone will result in failure. Fourthly, all changes must be deliverable with measurable outcomes that can be verified and monitored. I mean, you read so many statements, particularly at local government and state, even at federal government, and they're all words, but there's no commitment to do anything, and there's certainly nothing there that, by and large, can be measurable. Unless it can be measurable, we're wasting our time. Okay. Fourthly, I've mentioned those, but the fact that they must be measurable, and international agencies who will be monitoring Australia's progress will be measuring them, whether we comply with international obligations, and there will be penalties, even legal actions that may be imposed if we fail to meet them. Fifthly, success will require fundamental system change and a willingness to learn and apply lessons from the past and others who have been successful. This will require a ruthless approach that does not tolerate failure or compromise. And at the moment, it's all about compromise. Sixthly, the role of government at every level to create the environment for change and apply the levers that will force and accelerate change is absolutely critical. They must be agents of change, but that's an anathema to this federal government. But this will require political leadership and intervention from all levels of government, supported by the bureaucracy that must provide independent expertise and frank and fearless advice.